Today we are going to see how to sketch the root locus with real codes in lecture 6 of control systems, and this is Manila. To sketch the root locus of the system whose open loop transfer function is g of s equal to k divided by s into s plus 2 into s plus 4. Find the value of k so that the damping ratio of the closed loop system is 0.5. So in the previous lecture we detailedly solved using a step-by-step procedure and found out the value. In this video we are going to see how to draw the graph. So we have already found all the values in the previous lecture. I have included the link of that video in the description part. Now we can sketch the graph.
Now let us see how to draw the graph for the function g of s is equal to k divided by s into s plus 2 into s plus 4. So you know that the first step is to determine the poles and zeros. So here for this function we already calculated everything. So poles is 0, minus 2 and minus 4. So mark the poles 0, minus 2 and minus 4. So poles should be marked by the into mark. Right. So step 2 is to identify the area of the root locus. So here after each and every poles we'll be taking a test point, and then we'll be checking it the number of poles to the right side of it. Right. So in between 0 and minus 2 I can take the test point as minus 1. The right side will have only one pole, so it's going to be odd number. So we'll have the root locus in between 0 and minus 2. So 0 and minus 2 will be having the root locus. Then after minus 2, before minus 3, minus 4, I'll take a test point as minus 3, and right side of it I have 2, so it's even number, so there is no possibility of the root locus in between these two. After minus 4 till your infinite, I can take any value as a test point. Let it be minus 7. So right side of it I have 3 poles, which is going to be your odd number. So there is a possibility of test points between minus 4 to minus infinite. So this is your step 2. Step 3 is to get your centroid as well as your asymptote. So you have calculated the centroid. Centroid is minus 2, and then the asymptotes, angle of the asymptotes is plus or minus 60 and plus or minus 180. So plus or minus 180, there won't be any problem. It's going to be the horizontal line. So for plus or minus 60, so keep the protractor at the centroid, right? So the centroid, I'll be keeping the protractor, and then 60 degree. So mark the 60 degree. So your 60 degree is here. So mark the 60 degree. So connect the centroid with the angle of asymptotes in a dotted or dashed line. Similarly, this is going to be your plus 60. So we'll be drawing it for the minus 60 also. So keep your protractor at the centroid minus 2, and then draw the angle of asymptotes as 60 here. So this is going to be the angle, and draw the dotted line. Connect your centroid with your angle using a dashed line. So this is going to be another 60. Right. So next, what's your next point? It's going to be your step 4. You have found the breakaway point. So what's your breakaway point? Minus 0.845 is going to be the breakaway point. So note your breakaway point. It's going to be minus 0.845 is a breakaway point. So note this breakaway point here. Then your step 5, you don't have angle of departure and angle of arrival, as we don't have complex poles and zeros. So step 6, we found out at which point it crosses the imaginary axis. So it's going to be plus or minus 2.828J. So mark that point where it crosses the imaginary axis. It's going to be 2.8. So this is 2, this is 3, in between you have 2.8J. So this is 2.82J, and this is going to be a minus 2.82J. So now after marking this point, join the breakaway point with the imaginary axis using your pencil. So from your breakaway point, you just join the imaginary axis. So here this side same thing. So we have joined. So this is your root locus. So this is your root locus. At last, now for the damping ratio 0.5, what is the K value? So for that one, using your damping ratio 0.5, we found the alpha angle. Cos inverse of damping ratio will give you the alpha, which is nothing but 60. Right? So cos inverse of 0.5, we have found it as 60 here. So we will be getting an angle of 60. So at the point 0 as your reference, draw the 60 degree here. So this is going to be the 60 degree and then join this line. So I am just joining the center point to this one. So this is going to be the damping ratio. So damping ratio, this is the line angle, alpha angle for the damping ratio 0.5. So this is going to be your 60 degree here. So now what we have to do is, for finding your K value, you have to find the length to the poles here. So what is the length to the poles? So here the point at which it crosses the curve. So from this point, draw the line to all the poles here. So connect all the poles here. So from this point to your 0 pole is already connected, and from this point to -2. So that's going to be the next pole. So connected next pole. Then from this point connect -4. So now find the length of it, right? So L1 will be your, so from this point find the value of your L. So this L is going to be 1.1. So your L1 is going to be 1.1. And then your L2. So L2 is nothing but, so the distance between this pole 2 and then this point. So this is nearly 1.85. So L2 is 1.85, and again your L3. So from your point 4, that is your pole 4, to your meeting point. So this is going to be your 3.7. So 3.6. So your L3 is 3.6. So here we don't have zeros here. So your K value will be equal to L1 into L2 into L3 divided by 1. So which is nothing but 1.1 into 1.85 into 3.6 divided by 1 will give you the K value for the damping ratio 0.5. So this is the way to sketch the root locus.
Thank you guys. Have a nice day. Subscribe my channel for mathematical.